All right, get ready for a trip. We are about to dive into some of the most, well, mind bending truths about our universe. We're going to cover everything from the strange sounds of deep space to a scale so massive it's almost impossible to wrap your head around. Honestly, these are the kinds of facts that really remind you just how much is still out there waiting to be discovered. So let's start with a question. I want you to really picture it: the vast, dark emptiness between the stars and planets. What do you actually hear in your mind? Yeah, for most of us, the answer is complete and total silence, right? It's a vacuum. We all learned in school that there's no air for sound to travel through, and, well, that's what we've always been told. But what if I told you that's not quite the whole story? See, it turns out we can listen to space. We just can't do it with our ears. Spacecraft, like the legendary Voyager 1, have special instruments on board that can detect something called plasma waves. These are just vibrations in the charged gas that fills space. And here's the cool part. Scientists can take those vibrations and convert them into audio we can hear. It creates these incredibly eerie, almost spooky sounds. So no, it's not sound in the way we think of it, but it really is the voice of the cosmos. So, space isn't totally silent after all. And the very machines that taught us that, well, they're just the beginning of the story. So let's shift gears and talk about the incredible robotic explorers we've sent out to actually see things up close, starting right here in our own neighborhood. I mean, think about it. You've probably seen those amazing selfies from the Mars rovers, right? Like from Curiosity or Perseverance. But have you ever actually stopped and thought, wait, how does a robot, all by itself, millions of miles away, even do that? It's definitely not as simple as just holding out a phone and clicking a button. What the rover does is extend its long robotic arm, and the camera on the end takes dozens, sometimes hundreds, of individual pictures. Then, all those separate images get sent back here to Earth, where engineers painstakingly stitch them all together to create that one perfect, seamless portrait. It's really less of a selfie and more like an epic cosmic photo shoot. Of course, before a rover can take any pictures, we have to get it there in the first place. And trying to send a heavy machine across the solar system is, not easy. It takes an unbelievable amount of speed and some seriously clever thinking. So, to save a ton of fuel and a ton of time, engineers use this brilliant trick called a gravity assist. The best way to think about it is like a cosmic slingshot. You aim the spacecraft to fly really close to a huge planet, like Jupiter, and you use that planet's massive gravity to just whip the spacecraft around it. It gets this incredible speed boost and a new direction, all without burning any extra fuel. It's just a masterpiece of physics. And the absolute best example of this has to be Voyager 2's Grand Tour. It took advantage of this super rare planetary alignment that only happens once every 175 years. It used Jupiter's gravity to get to Saturn, then it used Saturn's gravity to get to Uranus, and then Uranus's gravity to get all the way out to Neptune. This kind of planetary hopscotch would have been totally impossible without the gravity assist. Just an amazing feat. And that amazing journey brings us to where the Voyager probes were headed all along. Because after they toured the planets, they didn't stop. They just kept on going, heading straight out into the great dark unknown, way beyond the influence of our sun. And this is a truly incredible moment for all of us. Back in 2012, Voyager 1 officially left our solar system. It crossed the boundary and entered interstellar space, that vast emptiness between the stars. It is, right now, the farthest thing from home we have ever created. Just try for a second to imagine that distance. Over 20 billion kilometers. A number that big is, well, it's almost meaningless, isn't it? So let's try to put it in a way that makes a little more sense. If Voyager 1 sent us a signal right now, even with that signal traveling at the speed of light, it would take more than 20 hours to get here. Think about that. A single radio message travels for nearly a full day just to cross the distance from that tiny probe back to us. And as it sails silently through that cosmic ocean, Voyager is carrying something special. The team who built it had the perfect way to describe its precious cargo. That message in a bottle is the golden record. It's basically a time capsule for our planet. On it, there are sounds of Earth, like wind and rain and whale songs. There's music from all over the world. And there are greetings spoken in 55 different languages. It's a snapshot of humanity, sent out into the void on the off chance that someday, somewhere, someone else might find it. So Voyager's journey into the space between stars is just monumental. But to really, truly get what that means, we need to zoom out. I mean, all the way out, and put everything we've talked about into its proper, grand, cosmic context. I want you to try and imagine every single grain of sand on planet Earth. All the beaches, all the deserts, every last one. It's a number so big you can't even really picture it. And yet, astronomers are pretty much certain there are more stars in the universe than that. Way more. Okay, so how on earth could we possibly know that? Well, thanks to incredible instruments like the Hubble Space Telescope, we've been able to look deep into space and estimate that there are hundreds of billions of galaxies out there. And each one of those galaxies has billions of its own stars. You do the math, and the conclusion is just staggering. You know, when you think about it all, from hearing the strange hum of plasma waves, to getting a selfie from Mars, to sending a message in a bottle out towards other stars, it all points to one incredible truth. For all of our amazing achievements, we are just getting started. And that just leaves you with this one final, humbling question. In this unbelievably huge universe, with so much we don't know, what do we point our telescopes at next? What mysteries are just waiting for us to find them?